Welcome back to the class. Today let's focus on surface area of a right circular cylinder. It is a topic under the chapter surface areas and volumes of ninth standard mathematics. It's in both CBSE syllabus and Karnataka state syllabus. As we did in the past, what we did in the past, we obtained a 3D figure from the planar figure. Correct. We obtained cuboids from the rectangles. We obtained cubes from the squares. Let's continue the journey. All right, same method. Okay. So now let's try to obtain cylinders from circles. Remember, circles are planar figures, cylinders are 3D figures. Okay. How to obtain this question, right? Now imagine stacking circular sheets, like what we did with rectangles. Okay, what shape would we get? Just imagine that. The left one is just a circular shape, and what we did was we stacked these circular sheets one above the other. Okay, what do we get? What do we get? Yes, we got a cylinder. And if it stands upright, we call it right circular cylinder, because its base, you know its base is circle and it's perpendicular to it. Okay, remember, its base is circle, correct, and all of them are perpendicular. Okay, the base is perpendicular to the way you stacked it. Think that way. So maybe the word straight, we the two way we can derive go back to the history and understand the meaning of it. One of the meaning which is relevant, I'm quoting here. Right is derived. It is derived from the Latin word, rectus. In Latin word, it means upright. It's straight. Okay, so it is very clear, right? So the circles, the circular shapes are straight, they stacked upright, one above the other. Correct. So that's how we call it as right cylinder. What do you mean by circular cylinder then? So the base is circular. Remember. So naturally it's a circular cylinder. It's a right cylinder. It's a circular cylinder. So we call it right circular cylinder. I think it's now clear, right? Now continue. So remember, not all cylinders are right circular. Okay. Let's see why. Look at the images here. In the first image, okay, it's definitely circular. Correct. This same thing I stacked it, but definitely not in the straight way, but in a slant way. Correct. So the angle is no more right angle. It is acute angle for all the reasons you think. So which is certainly, this, the cylinder is definitely circular, but remember, not at right angles to the base. The slant is not at the right angle to the base, right? So it is not a example of right circular, cylinder. Let's look one more example. Remember this. See, these are shapes which I stacked it one above the other in a right angle. Okay. Okay. Now it's a right cylinder, but remember this base is not circular, so definitely it's not circular cylinder. Okay, non-circular. These are the two examples of non-right circular cylinders. Okay, now onwards, remember, unless we particularly specify, right, cylinder means for all the reasons it is a right circular cylinder. Let's go with this assumption. Now that we understood what is cylinder, let's go one step ahead and find the surface area of cylinder. Okay, now we learned it, right? From the plane figure we obtained the 3D figure, that is from circle to the cone, circle to the cylinder we moved, right? Now let's try to cover this cylinder with the least amount of paper. How to, the question, the challenge is to cover it with the least amount of paper, and we have a clever trick. Look at it. What is that? We take a sheet. Okay, we take a rectangular sheet. See this rectangular left one, this one. Okay, and what should be its width is, this width should be equal to its height of the cylinder. Right? This is the width, right? This width should be equal to the height of the cylinder. Now onwards I'll call this as a height only. Okay, remember. And its length, the rectangular sheet's length should be perfectly wrapping around the base. Look, like length should be exactly perfectly wrapping around the base. Okay, so now what is this length? Exactly, wraps around the the cylinder. Now the area of this sheet tells us, now it's very clear, right? The area of this sheet tells us the curved surface area of the cylinder. It means the area of this sheet is equal to the curved surface area of this sheet. Clear? Yep. Okay. You observe one thing. Did you notice this one thing? What is this? The sheet's length is same as the cylinder's base, correct? This is a base, right? It's circle. Okay. The sheet's length is same as the cylinder's base, right? Okay. And see, this cylinder's base is circular, and what is circumference of a circle? It's 2 pi r. So now it is simple. Length of this sheet is equal to circumference of this base, which is equal to 2 pi r. And now it's very clear, right? So the curved surface area is equal to sheet area. Now you understood. And what is sheet area? Is equal to length into breadth. So length into width. And what is length? Length is nothing but base of circumference, right? The base circumference of this. Okay. And length I replace with base circumference, and width I keep it as it is. Of course, it becomes height. This should be height. Okay. Now curved surface area is equal to what? 2 pi r, that is base circumference, and height of the cylinder. Now it's very clear, right? What is the takeaway here? Curved surface area of the cylinder is equal to 2 pi r h, where pi is a constant, and which is 22/7. R is radius of the base. Okay, and h is height of the cylinder. Okay, now let's go one step ahead. Let's see, this cylinder, but we need to see for this cylinder, right? We need to close this upper and lower surfaces, correct? This surface and this surface. Okay, and of course top and bottom of cylinder has to be closed, covered. Now so it means we need two circular regions, each of radius r, correct? What is the radius of each circle? Radius of a circular region, a circle is pi r square. It means we need such two things, okay, this pi r square and this region is pi r square area, right? There are 2 pi r square now required. Okay, add them both to first total surface area. Now total surface area is equal to curved surface area, which is this one, and 2 times of this circular, to other circular, the circular regions area. Clear, right? How much is it? This is curved surface area is 2 pi r h, and the circular regions is 2 times of pi r square. This is 2 pi r square. If you take 2 pi r common, we have r plus h. Okay, this is the thing formula. So now total surface area of a cylinder is equal to 2 pi r times of r plus h. Now you think very clear, right? Remember, where r is radius of the base, h is height of the cylinder. Now let's practice, okay, and with an example. Okay, let's take 3. Savitri had to make a model of cylindrical kaleidoscope. See, she has to make a model of a cylindrical kaleidoscope for her science project. She wanted to use chart paper to make a curved surface area of kaleidoscope. See, this is the curved surface area, and what she wanted to use? She wanted to use a chart paper to make the curved surface area of the kaleidoscope. Now, if you can see in the figure, it's very clear, right? What would be the area of chart paper? What would be the area of the chart paper she is going to use? Okay, required by, and remember, if she wanted to make a kaleidoscope of length 25 centimeter, this length, or we call it as height also, because when it is stacked, standing. So what should be the make a kaleidoscope of length 20 centimeter with a radius of how much? This radius from center to the edge, right? How much? 3.5 centimeter. So you may take, of course, pi is equal to 22/7. Let's imagine, see, as usual, we start with given and we go for solution. And kaleidoscope, let's understand what it does, try to get some picture of it. Kaleidoscope is an optical instrument, remember, which creates mesmerizing patterns through the repeated reflections of light and objects. To simplify, I showed you some images which I created. Okay, looks like this guy is looking from here and seeing wonderful patterns through this kaleidoscope, right? Now what Savitri has to do, she has to create a model of such a kaleidoscope. Okay, and what we need to calculate, let's see what is given radius of the base is equal to how much? 33.5 centimeter. R is given. Okay, and height means this, when it's standing we can think it as height. Okay, height of a kaleidoscope is given, which is 25 centimeter. Okay, and what we need to find out, we need to find out the area of the chart paper required. That must be equal to the curved surface area of the kaleidoscope, correct? Naturally, because she want this much of a paper to completely cover the curved surface area of the kaleidoscope. Okay, so now what is the curved surface area of kaleidoscope? Just now we derived it. That is called how much? 2 pi r h, where r is the radius, h is the height of the cylinder. Let's substitute them. So 2 pi, I'm taking 242 by 7, r is as it is, h is as it is. Now 2 I'm taking 22 by 2 is in 3, radius is 3.5, h is 2.5, 25, sorry. So I marked red because 7 on the 7, 5 is the 35, right? So you can write it as 0.35. See, look at it, I can write it as 0.35. I got rid of 7. Now look at it, 7 and 0.5, 7 is 0.5 is half, right? 2 into half, how much? 1. I can ignore them. So what is the next one? 22 into 5, 22 into 25. So if you multiply them properly, you get 557 centimeter square, and this is a curved surface area of the cylinder. And she needs this much paper, the paper of this much area. This is an answer. Now that we did, let's close this now for now, and thank you for your interest, and all the best.